Hey everyone, welcome to Talk Tutoring. Hope you're having a great day. Today we are doing question 12 from chapter 13D. So this question has 3 objects instead of your typical 2. That's why I want to go through it, okay? So let's have a go into the question. This is once again connected particles, static dynamics. That's what we've been doing lately, okay? Right, question 12. The diagram shows masses of 8 kilograms and 12 kilograms right here lying on a smooth horizontal table. Yes. Whenever you see the word smooth, life is good. That means no friction. You don't have to consider, mu times n. You don't have to consider all these friction resistance forces, which is good. Not as much maths, right? Okay, and they are joined together by a light inextensible string to a mass of 5 kilograms hanging freely over here. Okay, pretty much everything's on the diagram. Quite nice. Let's keep reading. This string passes over a smooth pulley at the edge of the table. The system is released from rest. Find the tension in the string connecting the 8 kilograms and the 12 kilograms. So that is this tension right here. I'll call it T1. So they both have the same tension. And then the tension in the string connecting the 12 kilograms and the 5 kilograms, that will be this tension right here. Put in red so we can distinguish them. T2 and T2. Just be careful, they are not the same tension. They are separate strings, okay? So they can't have, they can have the same tension, but not necessarily the same. So we'll call them T2. Instead of T1 and T1, okay? Then we also need to find the acceleration of the system, okay? Now, first of all, whenever you're doing this question, label all the forces involved. So I'm going to label them quickly over here. You always have your weight force, 8G. You always have this force right here, that's 12G. Reaction force, same. They cancel each other out because it's on horizontal plane, so that's 12G. Then this guy has the 5G, which is your weight force. And we've already labeled tension, no external force. That's pretty much it. Okay, now you also need to label the direction of acceleration. Where is this system of, where's the system of objects going? Is it going to go down the inclined plane? Is it going to go down the plane, down the cliff? Or is it going to go to the left, across the table instead? Well, it's pretty obvious. Just use your common sense. If you got these 2 objects just at rest, lying on the table, nothing pulling it to the left, then it clearly has to go down, or going across to the right of the table because this guy is pulling it down. So the acceleration must be going down the cliff, down the table, okay? So that's our direction of motion. Acceleration equals to something which we don't know. Okay, now let's solve for the question. Part A, Part B, and Part C. Really, well, let's set up the equations. I think we can solve A, B, and C in the one go. So let's get our equations down. Equation number 1, let's look at the 8 kilograms object independently. What are the forces affecting it? Well, there's only T1, right? T1, and T1 is equals to 8 times acceleration. So 8, which is your mass, times acceleration, we don't know. So T1 equals to 8A. Nice. Okay. Let's have a look at the guy in the middle. So number 2, we have T2 and T1, and we know it's going to go down, so T2 must be bigger than T1, okay? So T2 minus T1, and that should equals to 12, which is your mass times acceleration. Remember, we are using resultant force equals to ma, that is Newton's second law of motion. You really should know this formula. It's your favorite formula in static dynamics, right? Then equation number 3, because we have 3 objects right here, we know 5G must be bigger than T2 because 5G, the force going down, it's pulling the object down and it must be bigger because we know the direction of motion is going down. So in that case, we have 5G minus T2 equals to 5A. All right, okay, so that's your system of, your system of equations. We've got 3 of them. We know T1 equals to 8A. So in that case, it's actually really nice. They work together nicely. You sub in 8A into T1. So in that case, you get T2 minus 8A, and that is equals to 12A. So therefore, very simple, T2 must be equals to 20A. Okay, and then once you got T2, you bring this T2 back into the third equation. So we have 5G minus 20A equals to 5A, and therefore 25A equals to 5G, and you can definitely solve for acceleration, which is G over 5. 5 over 25 simplifies to G over 5 meters per second square, and that's it. You got your acceleration. It's quite nice. And you can do this by hand. You can also use the calculator to solve for this, but really, I mean, doing it by hand, you get standard values, it's fine, okay? So once you got acceleration, you can easily find t1. What is t1 equals to? Well, we know it's equals to 8 times acceleration, so that's just 8 multiplied by g on 5, and that should be 8 on 5 times by gravity, meters, not meters, actually, it's in Newton, so that would be Newton, because it's a force. And if you want to solve for t2, we know t2 is just 20 multiplied by acceleration, so 20 multiplied by g on 5, that should just be 4 multiplied by g, and that is also in newtons. Right, guys, that's it for question 12. Very, very straightforward, okay? It's a smooth horizontal table, so nothing too difficult, no friction at all. Set up your equations 1, 2, and 3 because there are 3 objects. You should have 3 equations, and just solve for them, simultaneous equations. Right, guys, hopefully you found this video useful. If you did find it useful, leave a like, I'd really appreciate it. But aside from that, thanks for watching, and I'll see you in the next video.